Hi everybody, my name is Kavita Deodhar. My final project topic is AWS Redshift. AWS Redshift is a fast, fully managed petabyte scale data warehouse service which can be integrated with your existing ETL, that is extract, transform and load tools and reporting tools. It can be compared with data warehouse appliances like Netezza and Teradata and high performance hardware like Exadata. Here is the problem I'm trying to solve for my organization through the means of this demo. Our organization is looking at migrating the data warehouse environment to a better performing hardware and higher capacity which will meet our future data needs. The tool that we currently use for loading data, that is ETL, is Informatica, and the reporting tool is Tableau. We already have an extensive set of reports and dashboards that the executives of the organization heavily depend on. Hence, we want to move our technology that can cater to our needs without needing us to discard our existing ETL code and reports, and that causes minimal disruption to the users. This exercise is to verify if the existing tools in the organization can be easily integrated with Amazon Redshift. In this demonstration, we will go over the process of creating a new cluster on Amazon Redshift, create a set of tables to produce a mock report that shows sales in millions by day by region. We will use Informatica's cloud service to load data to Amazon Redshift and Tableau to read data from the tables created on Amazon Redshift to generate the reports. Now we are going to see how to create a cluster on Amazon Redshift service. For this, first log on to AWS Management Console. And then select Redshift service. As you can see on the screen, I've already created a cluster that I'm going to use for the next part of my demonstration. In this part, let us see how to create a new cluster. Click on Launch Cluster. Fill in the details about your cluster in this case, like the name of the database that you're going to create, the name of the cluster, which I'm going to choose to be my cluster, or rather my trial cluster. The name of the database is TrialDB. The master username, I'm going to keep it as master user. When you're given the password, please make sure that you follow the instructions as you can see on the right. It should contain one uppercase, one lowercase character, a number, and it should at least be 8 characters long. Please make a note of the password. In the next piece, we configure the node. We have a choice of 2 nodes, as you can see here, which is an 8x large or an x large. I'm going to stick to the smallest node here and choose x large. Also, there are 2 types of clusters that are available to us. One is single node and one is multi-node. For this demonstration, I'm going to use a multi-node cluster. There are 2 types of nodes that are available within the multi-node cluster. One is a leader node that directs all the requests and balances node between the compute nodes, and the other is a compute node, which is an equivalent of a worker node, which executes all the queries that you send to it. Here I'm going to choose the smallest possible size, which is 2. There are some additional configuration details that you can choose to fill here. At this point, I am not going to create a new cluster parameter group, so I'm going to stick to the default cluster parameter group. I am not choosing to encrypt the database. Also, let me choose the availability zone as US East 1B, and the cluster security groups I'm going to leave it as default and press continue. Here you can review all your cluster properties. As we talked about earlier, I get 2 compute nodes and a leader node when I choose a multi-node cluster here. This is going to be the availability zone US East 1B as we chose. You can see the database name that we chose is TrialDB, and the port is 5439. This is the port that accepts connections to the database. The master user is the username that we're going to use to log into the database. We stuck to the default parameter group as well as the default security group. we are not going to use the virtual private cloud in this case, and we are also not going to encrypt the database in this case. Next I say launch cluster. The cluster takes a few minutes to actually launch and create. Now let us go back to the cluster's dashboard and see. You can see that my trial cluster is being created at this point. We will keep refreshing until we see that the cluster status is available. As you can see now, the new cluster, my trial cluster, has now been launched and is successfully available. Let us see the details of this cluster. There are various tabs, as you can see, that are available. Here in the configuration tab, these are the cluster properties, the type, the node that we chose, the zone that it is available in, the security and the parameter groups. Please specifically note the cluster database properties. Here you can see that there is a JDBC and an ODBC URL that's written out. You can just select it in order to copy it. This is something that you will need to use in order to connect different tools to the database that you created here. I'm going to use the JDBC URL in order to use Workbench to connect to this trial DB, and we can see the demonstration in the next piece. This gives us a status of the cluster. Once we start running queries against the database, you will be able to track the CPU utilization, the throughput, as well as the queries that were run and how long they took to run. Again, we just created the cluster, we haven't started using it yet, hence you cannot see any queries, but once you start running queries against the database, you will be able to see what queries were run and how long they took to run. Again, right now we do not have any loads, but once we start doing loads, you will actually be able to see the copy statement as well as any other queries that were run against your database. Let us also see the properties of my DW cluster. This is the one that we will actually be using for the next part of the demonstration. These are the properties of my cluster. The zone that it is available in US East 1D, and the JDBC and the ODBC URLs. This is the status of the cluster. It is available right now. I ran some queries against the database, and hence there are some graphs that you can see for CPU utilization, network received throughput, as well as a couple of other parameters. Again, when I try to load a sample data set to another table, this is the copy statement that was generated, as you can see, and we can see that more in detail when we start loading our other queries. These were the other queries that I tried to generate against that particular database. So this is when I was selecting data from the test table. Now let's proceed to load data. Before we start loading data into this sales DB database, let us first create a couple of tables that we are going to need. For creating tables, we are going to use SQL Workbench. You can download SQL Workbench easily and then try to set up a connection profile. What I did basically was I went into File and said, clicked on Connect window. This gives you a whole, this opens up this window. You can name this window Sales DB connection if you like. Also, you have to choose the driver to Postgres SQL driver, as Redshift is based on PostgreSQL. Like I said before, copy the JDBC URL from this configuration page and paste it as the URL over here. This points to the my DW cluster, like you can see. This, and you can also see that connects to this database sales DB using the port 5439. Type in the username and the password. The password should be the same that you used when you created the cluster. The rest of the properties, rest of the checkboxes that you can see were already default. I did not make any changes. And then say OK. Now let us create 3 tables in the sales DB database. One is region dim, one is date dim, and the last one is sales fact. Region dim and date dim are the dimensions against which we are going to measure the sales amount which is stored in sales fact. Currently, there is no data present in any of these tables. Now we are going to use an ETL tool called Informatica to load data to these 3 tables. Now that we have already created our tables, let's start loading data in those tables. For the purpose of loading data, the tool that I have chosen to use is Informatica Cloud. Informatica Cloud offers a Redshift connector which helps us to load data directly to those tables from flat files that we create. You can sign up for a 30-day free trial after logging on to informaticacloud.com. Once you have already signed up for your trial, you have to install a secure Informatica Secure agent. The getting started video on this home screen can help you install the agent pretty quickly. Now that our agent is up and running, this is my agent which is up and running, and I can use this agent to set up a task which will load data from flat file sources into the tables that I created on Redshift. For this purpose, let me first show you how to create a Redshift connector. After you have installed your secure agent, you just have to check this Amazon Redshift box and the connector will be available to you. In the configuration tabs, click on connections, and now you have the option to create a new connection pool or edit already existing connections. I already have created an Amazon Redshift connection. So let me just edit and show you what all properties are needed over there. So when you decide to create a new Redshift connection, what you have to do is give a connection name which I'm calling Redshift. In the connection type, you have to go and choose Amazon Redshift connector. Then give the name of your secure agent, which in my case is Kavita Bio. Give the username and the password that you will use to connect to the database, which is master user. The schema wherein I created all my tables is public schema. AWS access key ID and AWS access secret access key is something that you already have on your from when you created your profile, and that's what you will use. The cluster node type that I used was XL. If you go on to Redshift and if you see the properties, what I used was XL, hence that is what I'm going to use in this case too. The number of nodes in my cluster again were 2, and hence the number of nodes I mentioned is 2. The JDBC URL can be copied from here, and as you can see, it points to my DW cluster and points to the sales DB database that we've already created. Let us test the connection, and we can see that the test for this connection is successful. It was able to successfully connect to the Redshift cluster. Now let us create a task which will help us to load data to the tables. As you can see here, I already created a task before this to load data to the region dimension table that we created. Now let us create another task which will help to load data to the date dimension table. Just give a task name give a short description. There are various task operations that are available to you. I have to insert data. I do not need to update data yet, hence I choose insert. Go to next. Now the source that I'm using here to load data to the date dimension is a flat file that I have created. This is a flat file that I'm going to load data from. Please remember that this flat file has to be present in the same location as your secure agent has been installed. I had a couple of issues installing the secure agent on this laptop, so I used a personal laptop wherein I installed the secure agent. Hence all the files that I've created are on the C drive in that particular laptop. Also the connection that I'm using, that is flat file, points to the files that are present in that laptop. So like we saw right now, it's the dates.csv that I'm going to try to load. If you preview the data right again, you can see that there are these records, or rather there are more than these number of records. These are just a few sample records that are present in that file. And we're going to go to next page. Here we configure the table that we are going to load data to. Like we saw before, Redshift is the connection that I'm going to use here. It's going to let us load data to the date dimension table that we've created in sales DB. It points us to date dimension. So currently there is no data present in the target table, and hence you can see that this is an empty table. These are the 3 columns that we have in that table. Let's go to next. We are going to process all the rows. We do not have to use filters at this point. Now let us see the field mapping. Here the year should be loaded to the year column. The month from source should be loaded to the month column in the target. Here also I'm going to drag and drop the dates pk onto the date pk here into the target. So we have mapped the field, every field from the source into every field in the target. Let's go to next and see the schedule. Here we are going to run this task on demand. We do not have to put a schedule in place right now, but just as an information, there is an option to put this task on schedule. I can get a default email notification when this task succeeds. Now a quick note on how data can be loaded to Redshift tables. Usually all your sources, all your flat files will be loaded to an S3 bucket, and a copy command has to be issued to load data from that file in that S3 bucket to the specific tables that we want to load data to. If in case you do not use a tool, this has to be done manually. You have to place all your source files into the S3 bucket of your choice and then issue a copy command to load data from the files that you placed in the S3 bucket to the target tables of your choice. Here I have already created a bucket in S3. Let me show that to you. This is the bucket that will be used to load data using Informatica into Redshift tables. So this is the bucket that I tried to use. Staging directory location, at this point I'm going to leave it to C drive. These are the rest of the properties wherein I can allow only one error to process before failing the job. Now let us save this task. So here's a task that we just created, load to datem. Before running this task, let me make sure that the agent that I'm going to use to run my task is active. So this particular agent, as we can see, is active. I go back to the data synchronization application and I press on this play button to run this task. Loading data might take some time. You will get an email notification on the email that you've registered to, saying that the task was either successful or failed. Also, the activity log will inform you on whether the task that you just triggered was successful or not. As you can see on my screen now, I have received an email that says that the load to datem was successfully completed. Let me go to Informatica Cloud and see if in the activity log, let me just try to refresh the activity log to see. Yes, now I can see that 24 rows were successfully loaded using the load to datem job. Let me go to the SQL and run this query again. I can see that there is data loaded to the date dimension table. Let us see a couple of things on the Redshift cluster dashboard. The loads. If you see the load tab carefully, there is a copy statement that was issued from my bucket that loaded data from the flat file that I had set up. And it loaded to the public datem table, the datem table on SalesDB. Let's go to the queries tab now. Also on the queries tab, you can see the sample query that we just executed, which was select star from the date dimension table, which returned 24 records. Here is the performance and the CPU utilization. It was a pretty flat chart when we had first created the cluster. Now you can see that activities have been mapped. Please also note the activities that have been mapped specifically for the leader nodes and the two different compute nodes. Now let's load data to the last table, which is the sales fact table. Before we proceed any further, I'm going to create another job to load data to the sales fact table. So getting an error when loading to the sales fact table, and it was due to the fact that the way I had defined this column, sales amount, was becoming a problem. When inserting a value thousands or 00, it was giving an overflow error. So I'm just going to create a table afresh, since anyway no data was loaded to it. I'll change the definition, the data type of that column from decimal 52 to decimal 102. Basically I'll change the precision. Created a new table again called sales fact. Now I'm going to have to refresh this particular mapping so that it does not give us any errors later on. So once I refresh the fields, it's automatically going to update the definition of sales amount. Just save and close this task. Let's try to rerun. Let's first check if the secure agent is again active. It is. So let's go back and try loading data to the sales fact table again. Again, it will be a while before it loads. And so we have this email that tells us that 50 rows have been successfully loaded to the sales fact table. Let's try to run a query and confirm this from the database as well. So yes, there is, you can see some data in the sales fact table too. Let us see what we can see on the dashboard for clusters. To my DW cluster, go to the loads, and you can see again that there's a copy statement that was issued. That loads data into the sales fact table from a file that was created in the S3 bucket Kavita Redshift. Let's go and see the queries that were performed on this table. You can see the select statement that we just ran, which returned 50 rows and completed in less than a few seconds. Again, we can see the performance tab with CPU utilization and everything that is graphed. Now we are ready to see if this data can be reproduced on any kind of a reporting tool. Now that our data has already been loaded to the sales DB, it is time to analyze that data. We have a sample report. I'm going to try and use a sample report in order to see how the sales work by region and by date. For the purpose of getting that report, I'm going to use a software called Tableau. I logged on to tablewsoftware.com and signed up for their free trial, which lasts for 14 days. You will also download a software for Tableau, which is pretty simple to install. Also, you will need to install the database driver for Amazon Redshift, which is nothing but a PL/SQL ODBC driver. So you just click on this version over here, and it's going to start downloading the PL/SQL ODBC driver for you. Since I've already installed it, I'm just going to cancel the install right now, and you can see that I already have this PL/SQL ODBC driver, and this is the Tableau desktop software that I had to install in order to use the business intelligence tool. Now, once our data has already been loaded, let us confirm that it's already all there. This is the data that as seen in the sales fact table. We are now going to set up Tableau. The first thing that we have to do before we create a report is to set up connection to our database sales DB. As you can see on my screen, we have an option to directly connect to Amazon Redshift database. So once I click on it, I have to give details like the server name, the database name, the username, password. Again, go back to the Redshift management console. Copy the endpoint in this case, which is your server. 5439 is again the port number that accepts database connections. The database on the server is sales DB. The username is master user. Password is what you already set up before. And say connect. So here now we will go and select the schema public, which shows us all the tables that we created, our date dimension, region dimensions, and sales fact. I can select multiple tables from this view at a point. This allows me to add different tables and also define the relationship. So for example, I can add the date dimension to this, which has all of these columns. Say I want to add sales fact. So the join between date dimension and sales fact is that the date pk should join the date fk that is there, and it should be an inner join. It should match 1 to 1. And I click on OK. Again, if I have to add yet another table, like I had to add region to it, I will also select region. Again, go to the joins tab. Sales fact will join to the regions table, not date dimension. So join the region fk to the region pk. It should be an inner join, and say OK. You can give it a name. I'm calling it demo connection, and click on OK. I have an option to either import all of the data onto Tableau's fast engine, or connect live, or import only part of the data. I'm going to connect live. Now this was the report that I actually connected using a connection called SalesDB. In here I imported the same three tables: date dim, region dim, and sales fact. I have defined dimensions and measures in this place, so which means these are the columns by which I am going to measure the sales amount. I decided to go with one of the reports over here, which are the highlight tables. The columns that I am going to put up over here are the sales region and the city, and the rows that I have is the sales year. So I have summed up the sales over here by this sales city, sales region, and for a particular year. If I wish to, I can also swap these columns, in which case my report is going to look in this fashion. So what this report means is, in 2012, the sales in Dallas, which belongs to the central region, is $1998. I can define that these are sales in millions, and I can add this as a tag here over here in the report. So let me edit the title and add a comment that says all sales are in millions. Similarly, you can create more tables into the SalesDB database, bring those tables into Tableau, and analyze the data further depending upon what you want to achieve in your organization. This is just a demo of what can be achieved over here. Now this screen that you see is in the build mode. If I have to present this report in a more formal way, I'm just going to go into the presentation mode, and this is how the report looks like. Creation of this report ends my demonstration. Final conclusion of my demo is that the existing tools can be easily integrated with AWS Redshift, and our existing code can also be reused. In spite of paying only for the resources that we provisioned, this service may tend to be a bit expensive, considering the cost for even the smallest node is 85 cents an hour. However, the cost aside, there are benefits like ease of use and scalability that this service has to offer, due to which it is definitely an option to consider if we decide to change our existing data warehousing solution. Thank you.